you just mentioned that you want to learn Python. So do not learn Python manual way 2027.
Okay, yeah, hi students, very good evening everyone. Welcome to Om Institute, and yeah, this is Rakesh Alreja, and yes, here we begin the champion series for GATE 2026 for all the upcoming to be champions of the GATE examination. Yes, guys. Okay, so champion series, as was conducted last year. This year also we have planned it, so that you get a lot of practice and revision around the GATE 2026 examination. The session named is as today is 21 champion questions, but it is not only questions. With questions we'll thoroughly understand how are you going to solve the questions. Okay, and the today's topic is classification of signal and system. Okay, and wherein the 21 questions are those necessarily 21 questions which is required to have a command on this particular topic. Okay, so that's how the questions have been chosen, okay, for the today's session. So quickly update all your friends that the session is live, okay, so that all others can join quickly. Okay, guys. Okay, all right. Okay, yeah. So okay, let's get started. By the time others will keep joining anyways. Okay, very good evening once again everyone. Okay, good evening Kanika, good evening Sai Shankar. Okay, so let us start with the questions here. Okay, so let me directly start with the first question about periodic signals. Now, classification of signals. Okay, two major important classifications in signals that you cover is number one, periodic and aperiodic signals. Okay, and number two is energy and power signals. Okay, important means in terms of questions. Okay, so starting with the concept of periodicity. Now, the first question is on continuous time domain. We will discuss discrete time domain as well. So, four signals are given x1, x2, x3, x4, and t1, t2, t3, t4 are respectively the fundamental periods of the above signal. Which of the following option is correct? Okay, I mean, we have to arrange the time periods in the increasing order, right? We have to arrange the time periods in the increasing order. Okay, so yeah, have a look into it, start solving. Good evening, Shalin. Good evening, Anindra. Good evening, Jyoti. Very good evening, all. Okay. Okay, so let's proceed forward. Let's proceed forward. Now, see, first of all, CT domain. Whenever, dear, you are in the CT domain, okay, the signals, the sinusoidal signals, A sin omega t and A cos omega t, as well as the complex exponential signal E power j omega t, they are always periodic. In DT domain, there is a difference, okay, but in CT domain, anyways, they are periodic, okay. So, if we talk about the CT domain, the sinusoids A sin omega t or A cos omega t or the complex exponential signal E power j omega t, they are always periodic. The difference come in DT domain, so we are going to take that as well. These are always periodic. How much period? Okay, having the fundamental period of 2 pi by omega. Omega, as you know, is known as the fundamental frequency. Okay, so I am just assuming that basic definitions and terms, still I am repeating it, but we will not write down the definition like what is time period, what is omega. But yeah, so that with this today's PDF you revise everything. Okay, I also have some notes for you. Okay, when I share the PDF in the Telegram, you can refer to the notes as well, like what periodic signal is. Okay, the signal whose value keeps on repeating after every fixed interval of time. Okay, like this particular signal, if you see, the value keeps on repeating after every 1 unit of time, and this is known as the time period. Now, if the value repeats after 1 unit, it repeats after 2 also, repeats after 3 also. But what is the smallest value of time after which repetition occurs? Is 1. So that is known as the fundamental period. Okay, the fundamental period. So have a look into it. Okay, as I just told, if the value repeats after 1, it repeats after 2, 3, etc. So if the value repeats after t, it will repeat after 2t, 3t, etc. So in general, period can be 2t, 3t, nt, anything. But what is the smallest value of time after which repetition occurs? T. Okay, that smallest value of time will be referred to as fundamental period. Okay, then reciprocal of time period is frequency. Reciprocal of fundamental period will be the fundamental frequency. In F, you can call it as, in the Hertz domain, it is 1 by t, and in the angular frequency domain, it is 2 pi by t. Okay, for a signal to be periodic, it must be periodic from minus infinite to infinite. Okay, some important points are there. Okay, so what I just told right now, that if you are in continuous time domain, the sinusoids, okay, they are always periodic, having the period of 2 pi by omega. Okay, but then when I talk about addition of periodic signals, because the signals given, okay, they are also talking about addition of periodic signals. Okay, so if two periodic signals are added, suppose x1 and x2, okay, x1 and x2, and not only x1 plus x2, generally you can consider this as a x1t plus or minus b x2t. Addition, subtraction, both allowed. Okay, so the resultant signal will be periodic if, okay, this is important. Okay, the addition or subtraction of two periodic signals is periodic if the ratio of their time periods t1 by t2 is a rational number. Okay, the ratio of the time period must be rational number. Okay, now if the ratio is rational number, they are periodic. Okay, so what is the final period? The final period will be given by, okay, there are two ways to calculate final period. You can take the LCM of t1, t2. Okay, or you can just simply cross multiply here, n into t1 or m into t2. The final period will be just cross multiply either nt1 or mt2. Okay, any of them is the answer, both will be equal only. Okay, or if you want to write down in terms of frequency this result, what is going to be the frequency? The frequency, okay, like if the t is LCM of the individual time periods, the frequency is the HCF of the individual frequencies, f1, f2. Same applies to, omega as well. Angular frequency is the HCF of omega 1, omega 2. Any of these things can be taken. Okay, so okay, we have some answers coming up. Okay, Shalem says answer C, Pandu Strike say answer C. Okay, so let's check it out. What is the correct answer? Okay, now see, as and when required. So see, I have brought a little bit theory so that when I share you this PDF, okay, you completely revise the topic. Okay, that is how the session is going to help you. Now see, let me start with the second one, e power j omega t. Okay, so what is the time period? This is 2 pi by 15 straight away. This is 2 pi by 15. Now first one is addition of two signals. Okay, let me first write down, okay, what is the omega, combined omega. Okay, HCF of, okay, HCF of 1 and 2. HCF of 1 and 2. What is the HCF? Because this omega is 1, this is omega equal to 2. Okay, now ratio of the time periods or ratio of frequency. Ultimately, dear, what is omega? Okay, what is omega? Omega is 2 pi by t. So if ratio of time periods rational, ratio of frequency also will be rational, because if you take ratio of frequency, 2 pi will get cancelled, na? Okay, so for the signal to be periodic, t1 by t2 must be rational. Okay, or you can also say omega 1 by omega 2 or f1 by f2. Any of the ratio you take, this must be what? This must be rational. Okay, that is important point. Okay, that is important point. Good evening, Bhanu. Okay, so going back to the first question. Yeah, so see, when you take the ratio of these two frequency 1 and 2, the ratio of 1 and 2 is 1 by 2. It is a rational number. What is the rational number? Ratio of two integers only. If pi comes in the ratio, then it is irrational. If you divide and a pi is left, then it is irrational, because pi is an irrational number. So what is the HCF of 1 and 2 is 1. So what is the first time period? 2 pi by omega. Okay, and 2 pi by 1 is simply 2 pi. Okay, now what about the third one? Okay, third one also, let me first take the HCF of the omega directly. Okay, what is the first omega? 6. What is the next omega? 8. And what is the next omega? 2. Okay, e power j omega t, omega is 2. Okay, so what is the HCF of these numbers? Will be 2. Okay, the HCF of 2, 6, 8 is clearly 2. So what is this time period T3? 2 pi by omega, and omega is 2 here. Okay, 2 pi by 2, and this is equal to pi. Okay. Okay, now fourth one. What is the fourth one? It is a combination of x5. So what is this x4? Okay, let me write down this signal x4 again. Okay, let me write down the signal x4 again, and I'm going to share you this entire PDF with you in the Telegram. Okay, plus x6t plus x6 3t. What will be x6 3t? Dear, I'm going to directly write down. If I replace t by 3t, 3t by 9 will be 1 by 3. So it will be pi by 3t. Got it, na? T will be 3t here. So 3 and 9 will get cancelled. So this is the actual signal x4t. This is the actual signal x4t. Okay. So what is the omega for this one? Okay. What is the omega for this one? Okay. Let us check the omega for this one. Omega here will be HCF of pi by 6. Okay. My number one question, when you take the ratio of omega, will it be rational? Ratio of time period or ratio of omega, anything. If you take the ratio of omega, when you divide them, both the omega has pi. And when you divide pi, pi cancel. Only what will be left? 6 and 3. Okay, so when you take the ratio, only integers will be left. 3 by 6 or 6 by 3. Which is a rational number? Ratio of integers is a rational number. Simple, na? Okay, see, if one signal had pi, another does not have pi. And then when you take the ratio, one pi will be left. Then answer will be irrational. Okay, that's the simple logic. Okay, now what is the HCF of this? HCF of fractional numbers. HCF of fractional numbers is HCF of numerators divided by the LCM of denominators. Okay, so HCF of pi is pi only, and LCM of 3, 6 is 6, the lowest common multiple. Okay, so it is pi by 6. So what is going to be the fourth time period is 2 pi by this omega, that is pi by 6. So that becomes 12. Okay, that becomes 12. Okay, now we have to see, what is first in the number. Okay, this is smallest, 2 pi by 15. Okay, then will come pi, then will come 2 pi. 2 pi is approx 6.28. Then will come T4. Okay, so what is the smallest? T2. Okay, what is the smallest is T2, correct? Then next I told T3, then T1. Okay, yes, B is the correct answer. B is the correct answer, not C. Not C. Okay, I got two answers as C, but no, C is not the correct answer. Okay, B is the correct answer, 2 pi by 15. See, you actually have to compare time periods, not frequency. Okay, check that also. The correct answer is B here. Okay, first is T2. Okay, 2 pi by 15, that will be smallest. Don't calculate, understood. Okay, next will be, okay, pi, which is 2 pi by 2. Then next is 2 pi. Okay, and then next is 12. 2 pi is approx 6.28, so 12 will be more only. Okay, so correct answer is option number B. Okay, I hope that is clear to all of you. Okay, next question. Okay, let us be ready for the next question. Okay, here it is. Okay, so yeah, some basic theory we have revised. As and when required, we'll keep revising. Now, DT signal. Okay, DT signal. What is the fundamental period of the signal? Now, again a sinusoid. Okay, again a sinusoid. Okay, the answer should be 2 pi by omega. That is 2 pi by 3. Okay, that is 2 pi by 3. That is 2 pi by 3. Not at all. Not at all. Okay. This answer is not correct because 2 pi by 3 is not an integer. And for discrete time signal, okay, the discrete time signal, okay, the time period compulsorily has to be integer. Okay, so this cannot be the time period here. Okay, this signal is actually, okay, this signal is actually aperiodic. See, the procedure is, let me tell you the procedure first. When you get a discrete time signal, okay, a sin omega n or a cos omega n, or same will apply to a e power j omega n also. This will be periodic if 2 pi by omega, if 2 pi by omega is a rational number. Otherwise, the signal cannot be periodic. Otherwise, the signal cannot be periodic. Okay, so what is the 2 pi by omega here? Okay, what is that 2 pi by omega here? See, usually students will do mistake, and this is one simple but expected question from DT periodic signals. Correct answer Sai Krishna, correct answer Salim. Okay, what is 2 pi by omega? The omega is 3. Okay, and this is irrational because pi is left. Now, pi is not a rational number. Okay, now since this is irrational, I can comment that the given signal is aperiodic. Okay, not periodic or aperiodic. Okay, so none of the time period is correct. It does not have a time period. It is aperiodic. Okay, right. Sai Bhargavi, correct answer. Okay, so D is the correct answer. It is not periodic. Okay, now let's go to the next question. Let's see some changes. Okay, this was clearly aperiodic. Okay, now look into this question number 3. Okay, so you can keep account of the question as well. As you know, the title is 21 questions for today. This is the third one. The signal sine 5 sine 150 pi t plus 30 degree is sampled at 200 hertz. What is the fundamental period of the discrete signal? Now see, Okay, although sampling is a different topic, can be covered in a different session, that alone is a important topic. So yesterday if you have seen that weightage distribution, chapter wise weightage I have shown you for signals. So sampling is like more important for EC. For electrical it is moderately important, and even if questions are coming from sampling for electrical, it is usually easier, but for EC you can expect good questions from sampling. Okay, but this is basic knowledge. Okay, how a sample signal is represented? Okay, the sample signal is represented by x of nts. Okay, by x of nts, represented by the notation x of nts. Okay, so what is ts here? Ts is known as 1 upon fs. Ts is sampling period, which is 1 upon sampling frequency, and given that it is sampling at 200 hertz. Okay, so this signal, okay, after sampling, okay, when you look at it into a discrete signal point of view, it will be written as 5 sine 150 pi t, t replaced by nts. nts, ts is 1 by 200 and plus that phase 30 degree. Okay, that is some initial constant phase, doesn't matter. So what is the signal now? It is like 5 sine of 150 by 200 cancels as 3 by 4. So 3 pi by 4 into n plus 30 degree. Okay, now you see what is the omega. Omega is 3 pi by 4. But one precaution I have added, what I have told you, a dt sinusoid may not always be periodic. Okay, Shalem has some answer, that is 8. This is a NAT question. Okay, now you see here, what is the 2 pi by omega for this particular question? What is going to be the 2 pi by omega for this question? Okay, for this question, the 2 pi by omega is 2 pi upon 3 pi by 4. Now, this time pi and pi cancel, no trouble, but 4 going above, 4 to 8 divide by 3. Okay, 4 to 8 divide by 3. So, now you see 2 pi by omega is the ratio of integers. Okay, ratio of integers is known as a rational number. So, is it rational? Yes, this is rational. Okay, this is rational. Sai Krishna also says answer as 8. Now, if this is rational, can I say the time period as 2 pi by omega? No, this is wrong. Okay, time period still cannot be 8 by 3 because time period I told you has to be integer. But what is the logic I told you? If the value of the signal repeats after n, it will repeat after 2n, 3n, 4n, 5n, 6n, etc. So, if the value of this signal repeats after 8 by 3, it will also repeat after 16 by 3. It will also repeat after 24 by 3. If I take multiples, it will also repeat after 32 by 3, etc. 24 by 3 is 8, which is an integer. So that is the correct time period. So the fundamental period is 8. It cannot be 8 by 3. If it was a continuous time question, you will say if the frequency is 3 pi by 4, the period is 8 by 3. There you can stop. But in dt, the period cannot be 8 by 3. Okay, the period cannot be 8 by 3. Okay, so that is what I mentioned here. First, what I told you, the dt signal is periodic if 2 pi by omega is a rational number, number 1 point. Okay, then the fundamental period is given by not only 2 pi by omega, it is given by, let me write it this way, 2 pi by omega into k. Okay, where k is some multiple factor. Okay, so that the final period is integer. Like I got 8 by 3. 8 by 3 into 3. What was k in our case? 8 by 3 into 3. 3 will cancel. Then you get the period as 8. Okay, so where k is the smallest integer, so that n becomes integer. Smallest integer means fundamental period you will get. Okay, the simple idea, you'll get fundamental period in that case. Okay, so I hope this concept is clear regarding discrete time signal. Now, okay, next question on discrete time signal again. Okay, now, okay, these are individual signals and then addition of discrete time signal. Okay. Again, n1, n2, n3, n4 respectively are the fundamental period of the following signals. Then find the correct option. Okay, then find the correct option. Okay, so see, what is x1n? Okay, what is x1n? 5 cos 0.2 pi n. So see, never say that the time period is 2 pi by omega. Don't blindly say. First check 2 pi by omega whether it is rational or not. Okay, whether it is rational or not. The first question or first signal, 2 pi by omega will be 2 pi upon 0.2 pi. Pi and pi cancel. 2 upon 0.2 is 10. Okay, now see, 10 is not only rational, it is directly integer. See, it is directly integer and hence rational also. 10 means 10 by 1. So, if you get 2 pi by omega directly as integer, then that is the acceptable time period. What I told you, the condition on discrete time period is it has to be integer valued. Okay, directly if you get 2 pi by omega integer, that itself is the answer, no trouble. Okay, so this is n1 equal to 10. Okay, coming to the second one, okay, 2 pi by omega, and that is 2 pi divided by omega 6 pi, which is 1 by 3. Okay, now 1 by 3 cannot be the period. Non-integer period not allowed in discrete time domain. So this is rational. Okay, not integer, but at least it is rational. Yes, where I saw one question where the 2 pi by omega was not rational. So I stopped and I told you the answer is aperiodic signal. But this is rational, correct. Okay, so what is the time period? N2 must be 1 by 3 into k. Some multiple of 1 by 3. Which multiple? Take 3. Take k equal to 3. Okay, you have to choose k so that you get a final integer answer. Okay, so that will be equal to 1 here, correct? Okay, so the N2 will be equal to 1. Okay, coming to the third one here, 2 pi by omega. For the third one, what is the omega? 6 pi by 35. Pi again cancelled. Okay, so it is 35 and 2 and 6 cancelled as 3, 35 by 3. It is again rational but not integer. Period cannot be 35 by 3, but the period N3 can be some multiple of 35 by 3. Again, which multiple? Third multiple suits here again. Okay, so answer is 35. N3 is 35. Okay, N2 is 1. Now what is left is N4. Okay, now the N4 is a combination. Okay, as an addition of two signals. Okay, what are the two signals? Okay, sine 5 pi n. Okay, now see, no trouble here. Actually, both are same only. X4 and see, both the frequencies are same only. Let me write down here only. Actually, it's a simple case. Both the frequencies are same only. Okay, so you know, if you consider the HCF part, okay, HCF of 5 pi and 5 pi will be 5 pi. Okay, HCF, because both the numbers are same only. The HCF of a comma a will be a. Okay, so what is the final frequency? Is 2 pi upon 5 pi. Okay, what is 2 pi by omega? Is 2 by 5, which is again rational. Okay, but not integer. It is rational but not integer. Okay, so what is the N4 period? N4 period has to be some multiple of 2 by 5. Which multiple? Okay, which multiple? Here it should be fifth multiple. Here it should be the fifth multiple. So 5 and 5 cancel, answer will be 2. So N4 is 2. Okay, so first is N2, then N4. Okay, smallest if I take N2, then N4, then N1, then N3. N2, right, then N4, correct, then N1, correct, and then N3, correct. So answer is B. Answer is B. Good evening, sweetie. Okay, yeah, Sai Bhargavi, B is the correct answer. Sai Krishna, correct. Shalim Manda, correct. B is the correct answer, dear. Okay, B is what is the correct answer. Okay, hope that is clear to all of you. Okay. Okay, yeah. Moving ahead to the next question. All right, a signal is given to you, xt. Okay, a signal xt has been defined as xt equal to summation minus infinite to infinite 2 delta t minus 4k minus delta t plus 1 minus 3k. Then the fundamental period of the signal is dash seconds. The fundamental period of the signal is dash seconds. So the question is only on fundamental period. Okay, but what the signal xt will look like? What the signal xt will look like? Okay, if I have a look of this, if I have a sketch of this, okay, then I may get some clarity, correct? Then only I'll be able to get some clarity. Okay, so see, let's try to plot this signal here. Okay, dear. See, if I take k0, just look into that, just tally the calculations with me. If I take k0, I get 2 delta t, that is the impulse at origin. That is the impulse at origin, and minus delta t plus 1, that's the impulse at t equal to minus 1, delta t plus 1, left shifted impulse, here it will be. Okay, then if you put k equal to 1, if you put k 1, okay, delta t minus 4, or let me first sketch this. Okay, let me only sketch this much part. Okay, let me only sketch this much part. Okay, correct. Shalem has the answer. Okay, so correct. Now, if you see, if I take k equal to 1, so delta t minus 4, impulse at 4. If you take k equal to 2, Okay, impulse at 8. If you take k equal to 3, impulse at 12, like this. Okay, so all these impulses have the area of 2. Now coming to the next, okay, let me explain you the logic of this question first clearly by sketching it. Now for the next, if you take k0 delta t plus 1, this is the impulse. If you take k equal to 1, okay, suppose if you take k1, okay, so you will get delta t minus 2, that is the impulse at 2, that is the impulse at 2. Now see, because of this 3k factor, this will be repeating after every 3, because if you take k equal to 2, now see, okay, so 1 minus 2, sorry, 3 to 6, so 1 minus 6 minus 5, so delta t minus 5, impulse at 5. So minus 1, then this was 2, then there will be an impulse at 5. Okay, so there are two parts, both of them are periodic. Okay, both of them are periodic with different periods. Okay, now next again will be see. Now see, there will be a overlapping at 8. Next again there will be an impulse at 8. This negative impulse. Also, because of the period equal to 3, there will also be an impulse here. This is minus 4. This was 8. Okay, so see, this presence of the double impulse at the same point at minus 4 and 8. Okay, so what is that repetition gap? Okay, this is the time period which is equal to 12. From minus 4 up to plus 8, how much is the distance? Is 12. Okay, so the fundamental period of this signal is equal to 12. Now you can see one thing. Okay, now what is a direct simple way? Okay, what is a direct simple way if we don't want to plot it? Okay, see, delta t minus 4k, if you keep plotting only this one, without plotting, just think in the mind. Okay, delta t, then delta t minus 4, delta t minus 8, delta t minus 12. So impulse is repeating after 4. Okay, that means the period will be 4. If I only focus on the first signal, period will be 4. If I focus on the second signal, because of the 3k factor, okay, repetition, minus 3, minus 6, minus 9. So gap will be 3 units. So second time period is 3. So what is the time period? It is addition of two signals. Is the ratio of time periods rational? Yes. The ratio of time periods is rational. 4 by 3 is rational. Then the final answer is LCM of T1 and T2. Okay, and LCM of 4 and 3 will be 12. That is a direct way of approaching this question. Okay, by orally analyzing the data, but I've just explained you by sketching the particular waveform so that the things are more better in your mind. They understood better in the mind. Okay. All right. Next question. Moving ahead to the next question. Okay. Now the signal. Sorry, this is not xt. This is xn. The signal, discrete time signal, sine pi by 2 n square. See, when it is sine omega n, you know what is the result, whether the signal is periodic or aperiodic. The condition 2 pi by omega I have explained to you. If 2 pi by omega is a rational number, the signal is periodic. But what about this one? Okay, sine pi n square inside. So see, when any new random signal is coming, okay, okay, for it to be periodic, what is the condition? This signal is periodic. Okay, if it satisfies what condition? If x of n is equal to x of n plus n. That is what the simple logic. If x of n equal to x of n plus n, it has to be periodic. That means the value of the signal repeats after every n units of time, and that n is known as the fundamental period. Correct? Then n is known as the fundamental period. Correct? This is what it is. Xn equal to x of n plus n. Okay. So if any new random signal given, and if you want to check whether it is periodic or not, you can simply say x of n should be equal to x of n plus n. Correct. X of n plus n. Yes, hers correct. Okay, Ricky, we'll try to plan that. Okay, so now see, what is going to be x of n plus n here in general? Okay, then we will substitute some values of n when required. Okay, so what is x of n plus n? Sine of pi by 2 n plus n whole square, and that is equal to, okay, let me open the bracket, sine of pi by 2 n square plus capital N square plus 2nn. Okay, now you see here, this is equal to sine of pi by 2 n square. Okay, if I open the bracket, plus pi by 2 times n square plus 2nn. Okay, what I want for the signal to be periodic? What I want for the signal to be periodic? X of n must be equal to x of n plus n. Okay, what is x of n? Is actually sine of pi by 2 n square. What is x of n plus n? As we have just calculated, that is sine pi by 2. Sorry, this is n square, small n square. This is equal to sine pi by 2 n square plus pi by 2 into n square plus 2nn. Okay, now, okay, Sai Krishna says answer D, that means not periodic. Now, this can be equal if, see, what do we know about sine theta? Okay, sine theta, if I say, is equal to sine theta plus something. Okay, sine theta is sine theta plus something, because this is theta common. Okay, this is theta common. Sine theta is sine theta plus how much? Plus how much? If that something factor, if that additional extra factor is 2 pi, then sine theta and sine theta plus 2 pi is periodic, is the same, na? Because sine theta value repeats after every 2 pi. Sine theta value repeats after 2 pi. So this question mark can be 2 pi, or not only 2 pi, 4 pi, 6 pi, etc. 4 pi, 6 pi, etc. Correct, na? Okay. So if this is a multiple of 2 pi, multiple of 2 pi means, okay, 2 pi into k. 2 pi into k, any multiple of 2 pi. Any multiple of 2 pi. Now see, option number A. Suppose this is periodic with period n equal to 1. Okay. It is periodic with period 1 or 2 or 4 or not periodic. Okay. Let me say, suppose the period is 1. Let me say the period is 1. Okay. Then whatever this extra factor, I will just consider that extra factor pi by 2 n square. What is n square? 1 square plus 2n into 1. Okay. So what I get here is 2n plus 1. 2n plus 1 into pi by 2. 2n plus 1 means some odd multiple of pi by 2. No, I want multiples of 2 pi or even multiple of pi. Okay, Ricky, correct. Even multiple of pi or simply multiple of 2 pi. Okay, so this does not correspond to 2 pi k. This does not correspond to 2 pi k. So A cannot be the answer. Okay, suppose the period is 2. Okay, so then this factor pi by 2, 2 square plus 2n into 2. Okay. Now, very clearly you see 2 and 2 got cancelled. Okay, pi outside. 2 and 2 got cancelled. Okay, then what is left is 1, 2 I have taken here, 1, 2 I have taken here. So, what is left is 2 plus 2n. So, 1 more 2 is common. And if you take 1 more 2 common, 2 pi outside, 1 plus n. 1 plus n. Okay, 2 pi outside, 1 plus n. Now, see dear, okay, this is actually 2 pi into k. This is actually an integral multiple of 2 pi. Why? Because n is an integer. So n plus 1 is also an integer. dt domain, na? dt domain. The time is always integer valued. Okay, so if n is integer, n plus 1 is the next integer. So anyways, n plus 1 is integer. And what are you going to get here every time? Okay, 2 pi into some integer. That means multiple of 2 pi. And whenever you write sine theta plus 2 pi or 4 pi or 6 pi, it will be sine theta. That means xn will be equal to x of n plus n. Okay, xn will be equal to x of n plus n. This will be true, yes, if I choose n equal to 2. Now dear, if n equal to 2, n equal to 4 will also satisfy. Okay, if n is 2, okay, 4 will also satisfy, 6 will also satisfy, but this is the fundamental period. Okay, by default, what answer you should place? If nothing is mentioned, you should answer by default fundamental period. Okay, so what is the period or fundamental period of the signal? Okay, that is going to be option number B. It is, see, this signal is periodic. See, some of you thought it cannot be periodic, but yes, it is actually periodic. Okay, but with period equal to 2. It is periodic but with period equal to 2. Okay. It is periodic with the period equal to 2. Hope that is correct. Okay. It is periodic with period equal to 2. Now, a small twist as a homework for you. Okay, everything is same. The difference is in dt domain, n is only integer. In ct domain, time can take any value. In CT domain, time can take any value. This is a homework for you. Same question in CT domain. But remember, the hint is, this is CT domain. The t can take any value. Not necessarily integer. Integer, non-integer, any value can be taken here. Okay. Any value can be taken here. Okay, dear? Got it? So think about this. What should be the answer if the question, same question is discussed in the continuous time domain? Okay. Coming to the next classification, that is questions on energy and power signals. Okay, let us try that. The questions on energy and power signals. Come on, tell me. The energy of the signal x1t is E1 and energy of the signal x2t is e power minus 3t minus 2 ut is E2. If E2 is a E1, what is the value of a? Now, again, before I start solving this question, let us revise quickly some fundamentals. As I told you, we will not only solve questions, but basic foundation required will revise, so that this session is like a revision and a practice session for you. Okay, revision come practice session for you. Okay, so how do you actually calculate the energy of the signal? Okay, the general formula for calculating the energy is given by integral minus infinite to infinite modulus, sorry, not modulus x square t, it is given by integral minus infinite to infinite modulus xt whole square. That is the correct way of writing it, modulus xt whole square dt. Okay, and if xt is real signal, okay, which very commonly could be given to you, if xt is real, then you can simply write down x square t dt. Okay, integral minus infinite to infinite x square t, or area under the square of the signal. Okay, area under the square of the signal. Okay, now the average power, also known as the time average power of the signal, is generally defined by limit t tending to infinity. Okay, 1 upon t integral minus t by 2 to t by 2 modulus xt whole square, again modulus xt whole square dt. Modulus xt whole square dt. Okay, where if the signal is periodic, I'll give you another version of this formula. Okay, the idea is, okay, to calculate the integral of the square of the signal for the range, how much range taken, minus t by 2 to t by 2 is t divided by the length of the integral. That is known as the average value of the power over the time. Now to generalize, okay, we take t tending to infinity. Okay, because the power, the instantaneous power of the signal is given by x square t. Okay, right. How these values coming up, I'm telling you, I'm not going to derivation, but a quick revision of the formula and the questions. Okay, and the questions. You can also, find this formula as limit t tending to infinity. That is also okay. Okay, if you want, you can take the integral simply from minus t to t modulus xt whole square dt. But if the integral is minus t to t, so what is the total length of the interval is 2t. So 1 upon 2t integral minus t to t mod xt whole square dt. Okay, this is how it is. Okay, so this is what is the formula for average power. Same formulas, only the integral mostly becomes summation are there for dt. We'll come to dt questions also. Okay, so these are quick revision slides for you. Now, the signals, okay, on calculating, which have finite value of the energy, okay, they are known as energy signals. So for if any signal, if the energy turns out to be between 0 to infinity, that is a finite energy, will be energy signal, and for every such signal, average power will be 0. Okay, easily proved but not required right now. Then if the energy is infinite and the average power is finite, okay, will be known as power signal. So energy signal is a signal simply having finite energy, and for this signal automatically average power is 0. Power signals are the signals which have finite average power. Okay, which have finite average power. Okay, so average power must be finite and automatically energy will be infinite for such signals. Okay, So this is how we classify the signal as energy signal and power signal. Some important points, then we go to that question. Okay, let's come to this one first. All bounded exponential signals are energy signal. The question is actually on the important class of signal known as bounded exponential signal. What do I mean by bounded exponential signal? Okay, it could be right-sided, left-sided, or two-sided, any type of bounded exponential signal. Okay, so this is a right-sided bounded exponential signal. See, exponential, okay, but bounded. Bounded means what? Bounded means finite. All the values of the signal must be finite. That is bounded exponential signal. So have a look into it. E power minus 80 decaying to the right, or e power plus 80. This is e power plus 80 increasing but to the left and stops because I've multiplied by u minus t. Okay, it stops at 1. It does not go to infinity. If I only draw e power plus 80, okay, then it goes to infinity. Okay, but I take u minus t. U minus t means signal left-sided. Ut is right-sided, u minus t left-sided. Okay, so that means all the values of the signal are finite, actually between 0 and 1. Okay. For both of these, okay, energy turns out to be 1 upon 2a. That you can directly note down. How do we calculate? Exactly by this formula as I told you. Okay, but for important and standard signals, you can note down. Okay, by this formula, simple integration, if you feed into the integration, you are going to get the answer very, very quickly. Okay, very, very quickly you will get the answer. Okay, so this is right or left-sided. Okay. Okay, so bounded exponential signal e power minus 80 ut or e power plus 80 u minus t, the energy is 1 by 2a. If it is two-sided bounded exponential signal, come here. Okay, so if it is two-sided bounded exponential signal represented as e power minus a mod t, e power minus a mod t, or also written as e power minus 80 ut, right side, and e power plus 80 u minus t, left side. Okay, so ut e power minus 80, right side, decaying 1. U minus t, left side, e power plus 80, increasing 1. So it increases to 1 and then starts decreasing. Overall, all the values are finite only, does not exceed 1. Okay. So this is again a finite signal. Okay, two-sided bounded exponential signal. Okay, the energy for this portion 1 by 2a, the energy for this portion 1 by 2a, both are separate portions, non-overlapping. So when I add the energy, I get the answer as 1 by a. Okay, but if it is unbounded exponential signal, e power plus 80, as I told you, alone e power 80, this is the graph. And if you take ut, means only right portion of it. If you take only right portion of it, this is the graph you get. That is 1 to infinity, it increases to infinity. That is what is unbounded case. Okay, right, or e power minus 80 decreasing from the left side, so it decreases from infinity to 1. Okay, it decreases from which value? Infinity. It starts from unbounded value. So these are unbounded exponentials. Okay, and the energy for both of them, okay, or even if you take the two-sided version of it, energy will be infinity. Okay, but what I told you as the important point, all bounded exponential signals are energy signal. Okay, all bounded exponential signals are energy signals. Okay. Then all finite duration bounded signals. Okay, I'll come to it. All, and then this also I told you, unbounded exponential signals are, okay, NENP signals. NENP as a short form we use to represent the signals which are neither energy nor power. Because for that unbounded exponential signal, energy also infinity, power also will be infinity actually. Neither energy nor power. Okay, NENP, neither energy nor power signal. Okay. Okay, when we do the calculation for step signal will be a power signal. Actually, let me tell you the data also. Okay, when you calculate the energy of it will be infinity, and when you start calculating the average power by the formula I told you, will turn out to be 1 by 2. Okay, so finite average power, unit step is a power signal. When you do the calculation for impulse and ramp, energy and power both will be infinity. So they are NENP signals again, neither energy nor power. Okay, periodic signals, I'll come to some questions around periodic signal again. They are generally power signals. Okay, they are generally power signals. Now, coming to the first point, all finite duration bounded signals. Example, the signal which is finite in duration and bounded signal means its amplitude is bounded. Okay, all the values are finite. Okay, all the values are bounded. Have a look into this example. Very commonly rectangle. Have a look into this rectangular example. What is the duration of this rectangle? Okay, minus t by 2 to t by 2, some finite duration. And what is the value? The maximum value up to a. That means bounded. Okay, that means bounded. So this is what I mean by finite duration. Okay, dear. Some important results, actually very important for you. And bounded means the value, the amplitude of the signal must be bounded. Okay, For a rectangle, the energy turns out to be a square t, that is amplitude square. A is the amplitude and t is the width. The rectangle can be located anywhere. It is not necessarily symmetric. This is just a reference. Okay, it is located anywhere, doesn't matter. What is required is the width. Okay, what is the difference between the starting and the ending point? Okay, so amplitude square into duration, amplitude square into width, okay, is the energy of the rectangular signal. Is the energy of the rectangular signal. Okay, again another finite duration signal. Okay, triangular signal. The energy of it is given by a square t divided by 3. A again means amplitude, the height of the triangle to be considered. T is again the width. Again, the triangle could be placed anywhere. What is only important is the width. Okay, the difference between starting point and the ending point. Okay, and one more case important for you is the half wave sinusoid. Okay, half wave sinusoid. Okay, so half wave sinusoid, you understand? Na? Okay, the half cycle of sinusoid. Okay, the positive, suppose I have drawn only the positive cycle of the sinusoid. The energy of it, again by calculating by the previous formula, will be a square t by 2. A means amplitude of the sinusoid, t means width. Okay, the duration 0 to t. Okay, whatever is the width. Okay, and then whole divide by 2. Whole divide by 2. Now we'll take questions around all these concepts probably. Okay, sometimes the questions may also ask you simply to check whether the signal is a energy signal or power signal. So these definitions are known to you. How do you calculate energy or power? That formula also be revised. Okay, so we had a basic quick revision. Now coming to question practice again. Okay, the energy of the signal x20 e power minus at ut is E1. What should be the E1? The formula is 1 by 2a. Na? Okay, for e power minus at ut, we discussed the formula is 1 by 2a. Okay, the a for this question is 1. Okay, so this is 1 by 2. Okay, now what about this one? Okay, I will have to first rewrite x2 like this, e power minus 3t, and when you open the bracket, this is e power 2, which is constant. I will write it separately into ut. Okay, okay, right. Okay. So x2t is e square e power minus 3t ut. Okay, Shalim, just remind me at the end. So see here, e square e power minus 3t ut. Now what is going to be the energy E2? Okay, for e power minus 3t ut, e power minus at energy is 1 by a. Okay, energy is 1 by 2a, sorry, 1 by 2a, a is 3. Okay, but is the energy going to be simply multiplied by e square? Is the energy simply going to be multiplied by e square or what? No. Okay, let me also tell you the effects of amplitude scaling on the energy. Okay, yeah, let me continue with the revision part first. Okay, have a look into it. Okay, if there is a energy signal xt whose energy is E, okay, then the energy of xt minus a, time shifting doesn't affect the energy. Xt minus a, xt plus a same. The energy of x minus t, time folding also doesn't affect the energy. But energy of a xt, if the signal is multiplied by a, the energy is multiplied by a square, because energy is proportional to the square of the signal, na? Square of the amplitude of the signal. So if you multiply amplitude by 2, energy multiplied by 4. If you multiply amplitude by 10, energy multiplied by 100. Okay, by 100. So if the energy of signal xt is E, for a xt, a square E, then time scaling will change the energy, because time scaling is what? Compression or expansion of the base. And then we have seen energy is also proportional to the base width of the signal. Okay, so time scaling energy is given by E by a, or more generally E by mod a, if by chance a is negative, E by mod a. For minus xt, energy will be same, because minus xt means you can take a minus 1, but minus 1 square is 1 only. Okay, if I talk about the similar results for a power signal. Okay, what happens for a power signal? Okay, if the average power of a power signal, okay, is P, okay, then again time shifting doesn't affect the power, time folding doesn't affect the power, amplitude scaling again scales the power, axt power a square P. Okay, time scaling will not affect the power as well. Okay, and minus xt same. Here, one thing is time scaling also doesn't affect, because time scaling will not only change the width, will also change the time period. Okay, and what is the power for the periodic signal? This one formula, I'm going to come to this one soon. Okay, for a periodic signal, actually, average power is given by 1 upon t, where t is the time period. Okay, t is the time period, fundamental period of the signal. Okay, 1 upon t integral over 1 time period modulus xt whole square dt. Okay, which we will simply write, we'll simply call this formula as let me simply call the formula as Et by T. What is Et? Okay, what is meant by Et here? Et means energy in one period. Okay, energy in one period. T means time period. Okay. So time scaling will affect the energy, the time scaling will also affect the period. Okay, and both are cancelled and the power, net power is not affected. Net power is not affected. Okay, we'll come to questions around this formula also when I take a periodic signal power question. Yeah, going back to the question number 7th again. Yeah. So I left a question mark here. What is this question mark? Now, the signal, you know the energy for e power minus at ut. Now, the signal is multiplied by some number a. The energy will be multiplied by a square. Okay. So, energy should be written as e square square. Okay. That becomes e power 4. Okay. Divide by 3. Let me rearrange it like this. Okay. E power 4 divide by 3 into 1 by 2. Can I write like this? Because 1 by 2 is the E1. So I can now write down E2 is how much? E power 4 divided by 3 into E1. This is the E1. Okay. So the question says that the E2 is E1. What is the value of A? Okay. What is that value of A? It is E power 4 divided by 3. Okay. Approximately, if you have done the calculation, you can let me know. This is the final answer actually. Okay. This is the final answer. Okay, yeah, let's calculate only how much is going to be the final answer then. E power 4 na, yeah. Okay, approx 18.2. Approximately 18.2. You can write. $18.2. Yes, Samuk Pradhan, correct. 18.2, final answer. Okay. So see, this question has used the energy formula for exponential, bounded exponential signal and also the amplitude scaling effect. Okay, amplitude scaling effect on the energy. Going to the next question, dear. Question number 8. Okay, a simple one. MSQ question. Okay. Out of 21 questions today, around at least 5-6 are MSQs. This is the first one for today, but 5-6 MSQs have come. A signal is given by e power minus mod t. A signal is given by e power minus mod t. Which of the following is or are true for the above signal? For the above signal. Okay. E power minus mod t. Two-sided bounded exponential signal. Just now I told you the story of this. E power minus a mod t. Two power bounded exponential signal. Two-sided bounded exponential signal. Okay, this is the energy signal, correct? Because what is the energy of the signal? The energy of the signal given by the formula 1 by A. What is A here? A equal to 1. Okay, so whenever the signal has a finite energy, it is an energy signal. Okay, it is an energy signal, correct? Is it an even signal or odd signal? Very clearly you can see the graph. Okay, it's even symmetric. Even symmetric means identical to left and right. When left and right differ in sign, plus here, minus here, then that is odd symmetry, na? Then that is odd symmetry. So what type of symmetry here? Even symmetry. Correct answer A and C. Two answers correct. MSQ question it is. Okay, two answers are correct for this MSQ question. Got it? Okay, next question. Just now we discussed about this one. Okay, this is again a MSQ. Okay, just wait for it. Let's go to a simpler question first. Yeah, come to this. Then I'll go back to 9th. Don't worry. Okay. Yes, Samuk Pradhan correct. A and C was the correct answer. Sai Bhargavi correct. A and C correct answer. Look into this one. Question number 10. This is also easy one only. Easy but expected, you know. Easy but expected. A signal xt is defined in the range -5 less than equal to t less than equal to 5 and it has an energy of 16 units. If a new signal is formed by transforming xt as given by 1 by 2 x of t by 2, what is the energy of the new signal yt? See. 1 by 2 x of t by 2. 1 by 2 x of t by 2. Okay, what is going to be the energy? For xt, the energy is E. Okay, suppose E is 16. Okay, so for xt by 2, okay, the energy of this signal, now number one, if any signal multiplied by half, okay, the energy will be multiplied by half square. Okay, then multiplied by how much? Okay, what is the xt energy? Xt energy is 16. So x80 energy, what is the 80? Time scaling factor, and the energy is given by E by A, as I told you, E by A. What is the A value? Half. So half will be further divided. So actually 1/2 will be get cancelled. Okay, so only half into 16, answer will be 8. Answer will be 8. Okay. Yes. Shalem, no, not 32, 8. Okay. You have, I think, only taken care of this one. Okay. The half is also there. Amplitude scaling and time scaling, both are there. Okay. So net answer is 8 actually. The net answer is 8. Okay. Not 32, Shamuka. Shamuka also told 32. No. It's 8. Have a look into it very clearly. Okay. 16 upon half is 32. That is okay. But 1 by 2, this extra factor is also there. Na? Correct. Yes, Harsh, correct. Okay. So answer is 8. No problem. Okay. No problem. But learn from mistakes. That's what. Okay. Yeah. Okay. Now going back to the 9th question. Okay, which of the following signals is or are energy signals? Which of the following signals is or are the energy signals? Okay, xt equal to t. Okay, so now see, xt is defined as t for t equal to 0 to 1. Let me draw the xt. Let me have a quick sketch of xt. The first one. Okay, in option number A. Okay, a signal is an energy signal if it has finite energy. Okay, let me see. What is the energy for this signal? Xt equal to t. Okay, t is between 0 to 1, and for t equal to 1 to 2, it is 2 minus t. Okay, see here. Xt equal to t, y equal to x. Straight line. Okay, simply a straight line. Okay, so see, when t equal to 1, okay, the signal also becomes 1. Okay, the signal also becomes 1. Then, for after t equal to 1, it is a line given by the equation 2 minus t. Now this is a line of slope, negative slope, means decreasing line. Okay, starting with the same amplitude, because if you put t equal to 1 here also, 2 minus 1 is 1. Okay, so from here you draw a line of negative slope, decreasing line. Okay, at t equal to 2, 2 minus 2, it stops at 0. So what do you get? Is a triangular picture. Is a triangular picture. Is it an energy signal? Yes. Okay, they have not asked the energy, but okay, let us calculate the energy. What is the energy for this signal? What is the energy for this signal? As I told you, a square into duration. Now this is what is a, amplitude, and what is the duration? 2 units. A square into duration divided by 3, 2 by 3. Okay, finite energy means energy signal. Okay, but yeah, anyways, you know, rectangle, triangle, all these signals coming up, it's energy signals only. Okay, next one, option number B. Okay, option number B. Okay, what is the waveform in option number B? This is again a MSQ question, so that is why I have to scan all the options. Okay, xt equal to constant 1 for any t between 0 to 5. Suppose this is 5 right now. For any t, it is constant 1, and then it is given again by an equation of line, minus t plus 6, negative slope, and at t equal to 5, 6 minus 5, 1. It starts from here only. Okay, and it goes up to which point? Okay, yeah, so you have to be very careful here that when t becomes 10, 6 minus 10, 6 minus 10 minus 4, it will go up to some amplitude minus 4 and then stop. If this t equal to 10, 6 minus 10 will be minus 4. Okay, this value has to be minus 4. Actually, they are not asking the energy. Okay, I'm just calculating for your sake. Is it an energy signal? Yes, it is an energy signal. Finite duration signal and bounded in value means it is an energy signal. Okay, you can tick mark. Okay, but what is the energy? Let us calculate. Let us calculate. Now for this much of the portion, dear, this is a rectangle portion. Energy of rectangle, a square into d. Amplitude 1 square into duration 5. Okay, duration 5. Then plus. Okay, then this is going to be actually 6, because when I take t equal to 6, 6 minus 6, 0. So it will cross a 0 axis, that is x axis at t equal to 6. So now there are two triangles. Energy of the triangle, energy of the triangular portion, a square. Okay, this is amplitude 1 and this is duration 1. A square into 1 by 3 And next triangle has how much of the amplitude? -4. This has the amplitude -4. Okay. So -4 square, amplitude square, into how much duration? 6 to 10 is 4 by 3. Anyways, finite energy. Okay, but how much is that finite energy? I'm just trying to calculate. 5, okay, plus 1 by 3, and this is 4 square into 4, 64 actually, 4 cube, 64 by 3. Okay, so answer is 5 plus 65 is divided by 3. Okay, so that is how much actually? 65 by 3, 21.67. So total 26.67. Okay, finite energy. Just for the understanding, I have done the calculation. Otherwise, if you see a finite duration bounded signal, it is energy signal. The question is only asking whether the signal is energy signal or not. Okay, then option number C. Okay, then let us talk about option number C. 5 cos pi t. Okay, xt is 5 cos pi t. Okay, -1 to 1. Let me draw the option number C here. Okay, let me draw the option number C here. Okay, at t equal to 1, okay, this way. Entire one period of cosine waveform is given. Okay, because the period of this signal should be, okay, 2 pi by pi, which is 2. So -1 to 1, complete period is given 2 units. Okay, cos minus pi is -1. So the signal should start like this with the value -1. And at 1, it becomes cos pi, which is again -1. Okay, cos 0 is 1. Okay, in between t equal to 1 by 2, so it will become cos pi by 2, which is 0. Okay. Now, ultimately, finite duration. See, if I give you entire 5 cos pi t, that periodic signal, that is a power signal. Okay. But it is only bounded in the interval -1 to 1. That means finite duration signal, and that means energy signal. This is an energy signal. How much energy? How much energy? Okay. Now, energy of this will be, okay, energy of this, okay, it's a combination of two half wave sinusoid. Okay, one positive cycle, and when you combine these two, it can be one negative cycle. Okay, so twice of what is the energy? Okay, what is the energy for a half wave sinusoid? Okay, amplitude square, 1 square into duration of this one, -1 by 2 to 1 is 1 divided by 2. Okay, so this is going to be 1. Total energy for this much portion will be 1 only. Okay, will be 1. Okay. Okay, so not 1, it is actually, it's going to be 5. Okay, into 5 square. So answer will be 25. This actually amplitude is not 1, this is 5. So this will be -5. So accordingly, answer will be 25 actually. But okay, finite energy, energy signal. Okay, now 5 cos pi t plus sin 5 pi t. See, now see the differences here. Let me write down some cases here. Okay, what is the signal given? Number 1, the signal given was 5 cos pi t -1 less than equal to t less than equal to 1. This makes the signal as finite duration. Okay, so that was an energy signal. Okay, C option we have solved. Okay, but if I only give you this signal, 5 cos pi t, then it's a perfect sinusoid, complete periodic sinusoid signal. Okay, 5 cos pi t. If I don't mention any range of t, means all value of time. Okay, then it is a periodic and power signal. What is the average power of sinusoid? Okay, average power of any sinusoid signal, this is something that directly must be known to you, A sin omega t or A cos omega t. A sin omega t or A cos omega t, the average power is given by A square by 2. Is given by A square by 2. But the D option, see, definitely D option is an addition of sinusoid, so it is not at all an energy signal. So if you want to just answer the question, you are done. The correct answer is option A, option B, option C. A, B, C, 3 answers are correct here. Okay, yes, Harsh correct answer, Sai Bhargavi correct answer, Samukha correct. A, B, C is the correct answer if I only wanted the energy. Okay, correct Samukha. So A square by 2 is the average power of sinusoid. But when two different sinusoids are added, okay, what about that result? Okay, if two different sinusoids are added, suppose you have xt which is equal to A1 sin omega t plus A2 sine omega t plus phi, sinusoids of same frequency. Addition of sinusoids of same frequency. Addition of sinusoids of same frequency. The power in this case is not additive. The power is given by P1 plus P2 plus A1 A2 cos phi, where phi is the phase difference between them. Phi is the phase difference between them. Yes, tomorrow you have a network session also, Dharun. Okay. Tomorrow you have a network session also. Then Thursday I will again take signals. Friday again network. So you have networks in the champion series. Okay. P1, P2 is same, amplitude square by 2. Okay, for sinusoid. A1 square by 2 plus A2 square by 2 plus A1, A2 cos phi. Okay, but if xt is given as A1 sine omega 1t plus A2 into sine of omega 2t plus phi, okay, omega 2t plus phi, okay. Now, these are sinusoids, addition of sinusoids of different frequencies, orthogonal. Okay, the power in this case is additive, simply P1 plus P2. Okay, simply A1 square by 2 plus A2 square by 2. These are the two cases that you must remember. Okay. Okay, so going back to the question, what is there in my question? Okay, 5 cos pi t plus sine 5 pi t. Okay, different frequencies. Okay, different frequency. So for D, although answer is not required, okay, but if I want to write down the average power, it is going to be simply 5 square by 2 plus 1 square by 2, because different frequencies are given. Different frequency. The power is directly additive. Okay, so 5 square plus 1 square, 26 by 2, this is 13. Okay, this is 13. D is not our option because we wanted energy signals. So energy signals are ABC. D is a power signal having the power of 13. Just for additional, concepts, I have done the 4 calculations also, which was not required, but we have done it. Okay, some additional learning will be there. What else? Okay. All right. Okay, so if you are learning, the good ways of solving the question, if you are being attentive, do not forget to press the like button. That is the attendance for the session. Okay. Yes, Samukha, mostly next week onwards, you will see, machines and power electronics also coming for EE core. Okay. Next question number 11, find the energy of the following discrete time signals. Okay, 2 discrete time signals, okay, are given. Okay, what is the energy for them? Okay, so for discrete time signal, okay, what is the energy formula as we discussed? It is generally given by summation of, see, both the signals are real signals. There is no complex signal with J mentioned. Okay, so energy is simply summation of x square n, otherwise mod x n whole square. That's what I told you. Okay, generally summation minus infinite to infinite. Okay, so for the first one, okay, the energy will be given now. Now, this first signal has un. Okay, so un only exists from 0 to infinity. The unit step starts from origin. So general limit is minus infinite to infinite. I will write 0 to infinite because the signal has un. Then square of the signal, 1 by 3 power n whole square, or you can directly take square of 1 by 3 first. So this is like summation 0 to infinity. 1 by 3 square is 1 by 9, then whole power n. And when you open the summation, you will be getting a GP. 1 by n power, 1 by 9 power 0, 1, anything power 0, 1, then 1 by 9. Next will be 1 by 9 square, that is 1 by 81. 1 by 9 raised to the power 3. GP with infinite terms, okay, a upon 1 minus r. Common ratio less than 1, so direct GP formula, a upon 1 minus r. 1 upon 1 minus 1 by 9, so that becomes 9 by 8. That becomes 9 by 8. Got it? Nine by 8. Okay, done. Okay, so E1 is 9 by 8. Second question. Now, UN minus 6. Okay, let me simplify the second signal first. G of n is cos pi by 3n, but only Okay, from n equal to how much to how much? Unit step starts at origin, but u of n minus 6 starts at n equal to 6, and when you subtract both of them, answer will again be 0 from n equal to 6. So the signal will be till n equal to 5. Got it, na? Okay, this un starts from 0. Un minus 6 starts from 6, and when this starts, 1 minus 1, 0. Okay, so till here 1, 1, 1, 1, 1, 1. Okay, but here again 0, 1 minus 1. Here again 0, 1 minus 1, like that. Okay, so this value will be 1 only from 0 to 5. From 6 onwards, it will become 0. Okay, from 6 onwards, it will become 0. Okay. Right. Shalem at the end, take that additional doubt at the end. Let me go in the flow right now. Okay, so now when n is only between 0 to 5, let me, actually calculate the values of this signal. Okay, it's going to have only 6 samples here. Okay, starting with 0, cos 0, 1, then cos pi by 3. So cos pi by 3 means 1 by 2, cos 60 degree. Then n equal to 2, so cos 2 pi by 3 minus 1 by 2. Okay, I'll write down for your reference n values 0, 1, 2, 3, 4, 5. Okay, when I write down 3, so 3 and 3 cancel, cos pi minus 1. When I write down 4, so cos 4 pi by 3 again will be minus 1 by 2. So third quadrant, and cos 5 pi by 3, that will be how much? Fourth quadrant, that will be plus 1 by 2 actually. Correct, na? Cos 5 pi by 3. Correct. Okay. All right. So that is how it can be written. Okay, these are the values of Gn, and then what is the energy E2? The energy E2, again, if you open the energy as summation of the square of the signal. Okay, so very simply, just have to take the square. 1 square, okay, 1. Okay, 1 by 2 square, 1 by 4. Minus 1 by 2 square, also 1 by 4. Minus 1 square plus 1 only. Minus 1 by 2 square plus 1 by 4. 1 by 2 square again 1 by 4. Okay, so how much is the net answer? 1 by 4, 1 by 4, 1 by 4, 1 by 4. Okay, 4 times. So that is 1, 1, 1, 1. Net answer 3. This answer has to be 3. Anybody? No? Sai Bhargavi told the first answer correct. Shalem told first answer. Samuka also told first answer. First answer you got it as 9 by 8, which is okay. Okay, but the second one is 3. Let me know if there is any doubt in the second one. The correct answer here is equal to 3. Okay. Yeah. Next question. The waveform of a periodic signal is shown in the figure. The signal Gt is defined by x of t minus 1 divided by 2. What is the average power of Gt? What is the average power of Gt? Now you see, first of all, okay, what is xt? A periodic signal is given. Okay, for a periodic signal xt, okay, how do you calculate the average power? I told you for periodic signal Et upon t, energy in one period divided by time period. Energy in one period divided by time period. But now the signal Gt is given by x of t minus 1 divided by 2. Let me tell you, let me give you a reminder that if xt has the power p as p average, what is the power of xt minus half? Time shifting doesn't affect the power. Okay, then x of t minus 1 by 2, I am breaking like this, t by 2 minus 1 by 2. What is the power here? T by 2 minus 1 by 2. That is also p average. That is also p average. Got it? That is also p average, because time scaling, it affected the energy of energy signal, but what I told you, time scaling doesn't affect the power of power signal. So it is p average. Okay, p average means whatever is the power of the signal xt, and let me again write down the power of the signal xt is Et by t. Okay, so it's not that you have to sketch another waveform Gt. You can directly calculate the xt power, and that will be the Gt power. Correct, Sai Bhargavi. Both will have the same power. Okay, both will have the same power. Okay, so yeah, let me write it here only. Both will have the same power, and that is Et by t. Okay, now what is the time period? Now time period is the time for repetition. Suppose if I start from the first positive cycle, this is the positive triangular cycle, starting from -1 and going up to 2. Another positive triangle starts at 2. How much is the gap? 3 units. -1 to 2, the difference is 3 units. Okay, the time period of the signal is 3. Okay, now what is the energy in one period? In one period, you have a positive triangle and you have a negative triangle. For any triangle energy, a square d by 3. Correct, na? Amplitude square into width into duration, whole divided by 3. So what is the amplitude here? 3. And how much is the width here? 1. Okay. 3 square into 1 by 3, a square into duration by 3, correct? Plus, what is the next one? Amplitude minus 3 into duration, duration is 1, divide by 3. Okay, so 3 cancel, 3 plus 3, 6, 6 by 3, net answer 2 units. That's it. The net answer is 2 units. Correct, Samukha, correct, Dharun. Net answer is 2 units. Okay, fine. Answer is 2 units. Okay, next question, dear. Next question. Yeah, average power of the signal, xn equal to minus 1 whole power n. See, what is the pattern of the signal? Okay, firstly try to see what is the pattern of this particular signal. Okay, just check it out, everybody. Okay, what is the average power of the signal? Minus 1 power n. Let's have a look into it. See, minus 1 power 0 will be 1. Okay, if you see the pattern, okay, if I start from origin, the signal, there's no range given, the signal can be from minus infinite to infinite, but suppose if I take origin, minus 1 power 0 is 1, but minus 1 power 1 will be minus 1, minus 1 square again plus 1, minus 1 power 3 again minus 1. So, see anything, minus 1 power even will be plus 1, minus 1 power odd will be minus 1. Okay, this is the origin, n equal to 0, then 1 minus 1 will alternate. So, that is how we have built a periodic signal. It is a periodic signal. Okay, how much is the period? The value repeats after every 2 units of time. 1 minus 1, then again 1 minus 1. So, after every 2 units of time, values are repeating. That also is okay. Okay, so the time period is 2. But again, because it is periodic signal, okay, how do you calculate the power? The average power is given by energy in one time period divided by time period. For discrete time, let me write it as En by n. En by n. Okay, right? En by n. Okay, I think the comments are hidden. Just a second. Right. Okay, yeah. So Harsh is writing it as cos pi n. Okay, Shamukha is saying the answer as C. No, it's not infinite. The energy would be infinite. I'm asking the average power. Now, what is the energy in one time period? Okay, what is the energy in one time period for the signal? That also you can check now. Okay, what is the energy in one time period? What is the one period? 1 and minus 1. Energy is summation of the square. 1 square plus minus 1 square whole divided by 2. So 1 square is 1, minus 1 square is also 1. Okay, so 1 plus 1, 2, divide by 2, net answer is 1. Answer is A. Answer is A. Okay. Okay. Now see Harsh, that is the reason I have not given this question in the form of sinusoid. That formula A square by 2, okay, applicable for CT sinusoids. See, DT sinusoids, okay, there isn't generally the average power formula because they may or may not be periodic. Number one reason, Harsh. Second, even if they are, if 2 pi by omega is a rational number, we cannot always say that that is the period. It may be rational but not integer. So we have to convert it to integer by that k factor, by that questions we discussed in the beginning. Okay, so that's why we are just solving it by the fundamental formula, energy in one time period divided by time period. Okay. Okay, chalo, anyways, next question. Okay. All right, which of the system below is or are linear? MSQ question. Now coming to, linearity, time invariance, causality and etc. Yeah, you can draw the graph also, Prachi, no problem. You can draw the graph 1 minus 1, what is there? Alternate 1 and alternate minus 1. But the graph will be discrete graph, remember Prachi. Okay. Yeah, come up here. Which of the systems is or are linear? Let me see how many of you first can answer this one and then I'll, revise the linearity. Come on. Samukha says A and C. Okay, MK also says AC, right? Yeah, so answers are already ready. Sai Bhargavi AC, Harsh also says AC. That means this point is clear. Now see here, I'll just come up to this. I'll just come up to this. See, if you have to, now see, linearity, time invariance. If you go and solve every question, it will be time taking. So we need to have the direct conclusions out of it. See, if you want to have the standard definition, a system is linear, which follows superposition. Which follows superposition. Now, superposition is finally broken into two properties: homogeneity, that is scaling, and additivity. Okay, what is scaling? Okay, what is scaling? If input xt has the output yt, okay, if input st has the output yt, then kxt should have the output kyt. That means if the input is scaled, amplitude scaled by k, output should also be scaled by the same factor k. Okay, what is additivity? Okay, what is additivity? Additivity, if the input is x1t, output is y1t. If the input is x2t, output is some output y2t. But if the input is x1t plus x2t, the output will be y1t plus y2t. That is additivity. That means if two different inputs are added, their corresponding outputs must be added. Okay, then the system is said to follow additivity. Okay, the system which follows both additivity and scaling is said to follow superposition, and the system which follows superposition is said to be linear. But let me tell you, okay, linearity, okay, when the output yt depends on x power 1t, which only depends on x power 1t, okay, which only depends on x power 1t, is linear. Okay, that means if you talk about y versus x, the graph between y versus x, it should be a straight line passing through origin. Y versus x. Okay, whenever y versus x is a straight line passing through origin, okay, that is a linear system. That is a linear system. Okay, that means if I write down yt equal to, suppose some number m into xt, this is linear. Okay, but if I write down yt equal to m into xt plus c, which will be a straight line but not passing through origin, non-linear. Okay, yt equal to x square t, parabola. Okay, it's a clear non-linear relation, square device, parabola. Or if you write down yt equal to sine of xt, etc., all these are non-linear. All these are non-linear. Y should depend on x power 1. Okay, not inside sine, not sine x power 1. No, it should only be a x power 1 function, not inside sine, not inside log, not inside exponential. Okay, now another case is, what about this one? Okay, there is t square xt. Okay, but see, there is one option t square xt, but finally y depends on x power 1, separate function of time. So any separate function of time multiplied outside will not affect the linearity. This will still be linear. Okay, generalizing. Okay, whenever you get the question, I'm giving you direct conclusion without any proof. Okay, you can prove it. If you want to prove, you can attend my other videos on, the linear and time invariant systems or classification of systems as well. Okay, see, yt is equal to ft into xt. Okay, any separate function of time, but output depends on x power 1. This is linear. This is linear, correct? That separate function of time will not affect linearity. Then next case could be like this: y of t is equal to x of t square. Okay, square, non-linear, but on time, inside the bracket, on the time argument, this will still be linear. Okay, yt x of any function of time inside gt, any function of time inside, this will be linear only because y depends on x power 1. Okay, but yeah, if the question was like this, okay, suppose if the question was like this: y equal to x cube t power 4. Okay, then there is no role of t power 4. Okay, because x cube itself, this x cube itself is non-linear. This x cube itself is non-linear. What I mean is, if y depends on x power 1, then any change in t inside the bracket or any separate function of time multiplied outside, okay, will not affect the linearity. Okay, so yt equal to 3xt, line passing through origin, linear. Okay, e of x power t, no, exponential function, non-linear. X square, square function, non-linear. Okay, t square, see, y depends on x power 1, enough. That separate t square, as I have discussed separately also, okay, will not affect the linearity. Y depends on x power 1. The relation between y and x is important here, okay? Okay. So correct answer is A and C. Now next case. Then we'll come back to more questions on linearity. Let me have a question on time invariance. Then we'll mix up the things, okay? Which of the systems is or are time invariant? Consider the following system with input xt and output yt. Okay. Now what is the concept of time invariance? If y square, then x function. Dharun, are you saying something like this? Okay, I'll just write down this separately. Okay, are you saying this relation? Okay, suppose if you are telling this way, y square t equal to xt, x power 1 but square on y. This is also non-linear, na? Why? Because you can write down yt equal to root over xt. Root over xt means x power half function, non-linear. Line passing through origin. Line, see, if you want to see graphically, what is y square equal to x? Y square equal to x is a parabola opening, right? Non-linear, na? For the linear function, y depending on x should be a straight line, that too passing through origin. That too passing through origin compulsorily, okay? Now see, here, the again MSQ question, which of the system is or are time invariant? Which of the systems is or are time invariant? That we have to check here. Okay, see, this is definitely non-linear. Okay, square, non-linear. Okay, but is that x square anything to do with time invariance or not? Okay, let us just go through the definition first. Okay, a system is time invariant if a time shift in the input gives the similar time shift in the output. Okay, the behavior of the system doesn't change with time. Okay, what I mean here is, let me write down simply, if xt has the output yt, then x of t minus t naught, input delayed or advanced, anything, a time shift in the input should give the similar time shift in the output. Y of t minus t naught should give the similar time shift in the output. Okay, that means we say that the input and output are synchronized. Whatever shift is given in the input, whether it is delay or advance, the similar shift appears in the output. They are synchronized in the time. Okay, now if you wanted a systematic procedure, na, okay, what I told you, okay, what I told you first, just for your revision, I'll tell you the method. What is the method or steps to check? Okay, step number 1. Okay, step number 1. Okay, take delayed input x1t. Delayed input means x of t minus t naught, and call this input as suppose x1t. Okay, then you calculate y1t due to x1t. Okay, then number 2, take or directly calculate, do this way. Directly calculate y2t equal to y of t minus t naught. Okay, now if the input applied is x of t minus t naught, output should also be yt minus t naught. That means this output y1 should be equal to this output y2. Okay, got my logic? I'll tell you once again. Okay, if the input is xt minus t naught, expected output, if it is time invariant, expected output is yt minus t naught. Okay, yt minus t naught is suppose y2. That means this expected output y1 should be equal to y2. Okay, so if these two are equal, then the system is time invariant. If y1 not equal to y2, we say that the system is time variant. We'll say that the system is time variant. Okay. Okay. Now, understand this. Understand this. Okay, 3 cases I will write down here. Yt, let me explain you this one very clearly, x square t. Okay, Yt equal to t square of xt, t square into xt. And third case, Yt equal to x of t square. Wherever some explanation required, I am telling you. Okay, now see this. Okay, in the first case, okay, step number 1, I will take the delayed input. What is the meaning of delayed input? Take the input as x of t minus t naught. Calculate output y1t. What is output? Square of the input. Square of x1. Okay, square of x1. Okay, so what is the square of x1? Will become x square t minus t naught. Correct, na? Okay, then step number 2, calculate the output y2t. What is the output y2t? What is the output y2t? Okay, output y2t is y of t minus t naught. Step number 2, what I told you, take it as y of t minus t naught. Okay, and y of t minus t naught, if you change this t, right side you will change the t as t minus t naught. So x square t minus t naught, but both are same, na? y1 equal to y2, both are same, the system is time invariant. Okay, coming to the next case, again step number 1. Okay, step number 1, I will take the delayed input. What is the delayed input? X of t minus t naught. Calculate the output y1. What is the input output relation? Be very careful. Okay, now everybody be careful. The output is t square into input. T square into input. What is my input? x1. So my output is t square x1. My output is t square x1, correct? My output is t square x1. Okay, everybody followed? Now next. Okay, now next. What is y2t? What is y2t? I told you, calculate y2t directly as yt minus t naught. Calculate yt minus t naught separately. So if I replace here t minus t naught, okay, where will be the replacement on the right side? Every t on the right side, every t on the right side will be replaced by t minus t naught. So t minus t naught whole square, x of t minus t naught. Okay, now here, okay, here let me replace the x1t finally. So if you, in the first step, if I replace x1t, what is x1t? X of t minus t naught. So here t square xt minus t naught, here t minus t naught square x of t minus t naught. That means y1 and y2 here are not same. That means the system is time variant. The second one is time variant, right? Okay. Now Satyam says first time invariant correct, second time variant correct, third you are telling time invariant. Time to check the third one. Again, same procedure. Step number 1, x1t. Okay, take the x1t as xt minus t naught. What is y1t? Now, what is the output input relation here? Output is x of t square. So, if the input is x1, I will write down output as x1t square. That's it, na? Simple, x1t square. But what is x1t square? Any change in t will be reflected here. T naught is constant, remember. Any change in t, okay, will be reflected only on this t. Okay, so that is t square minus t naught. But step number 2, I write down y2t directly as y of t minus t naught. What is yt given? X of t square. So here, any t you change will be changed here. That means x of t square, but t becoming t minus t naught. So t minus t naught whole square. So here you have t minus t naught whole square. There you have t square minus t naught. Both are not same. Both are not same. y1 not equal to y2. So this is again time variant case. This is also time variant case. Let me summarize. Let me summarize that whenever you have any separate function of time, the system is time variant. Any separate function of time. This is what I mean by separate function of time. This is what I mean by separate function of time, correct? Okay, and this is what I mean by changes in time argument. Any change in time argument inside bracket, Time argument means argument inside the bracket, any change. Okay, then also the system will be time variant. Okay, now once again see three different cases. Suppose the question is yt equal to sine of xt. Next question, yt equal to sine t into xt. Next question, yt equal to x of sine t. Look into these three cases. Again, you will understand better. Okay. The first case, okay, how the output depends on input, sine of x. Only x power 1 function is linear. Sine x, e power x, cos x, they are non-linear. So this is non-linear. Okay, but is there any separate function of time? What are the factors making the system time variant? Okay, that you see. Okay, so is there any separate function of time? No. Okay, is there any change in time argument inside bracket? No. So this system is time invariant. Directly you look and answer now. Okay, next case. Now see, y depends on x power 1. Y depends on x power 1. The system is linear. But separate function of time, the system is time variant. This is the separate function of time case. Okay, separate function of time, ft. Okay, ft. Now, next case, again, y depends on x power 1. Y depends on x power 1. This is again linear. Okay, this is again linear. Any doubt, you let me know. Y depends on x power 1 linear. What is changed is the bracket time. That does not affect the linearity, but that affects the time invariance. That is what I meant. Any changes in time argument. Okay, so this particular question is what is this case. Any change in time argument. Any change in time argument will make the system time variant only. Okay, now let me go back to the question. Okay, yeah. So I'll just add on non-linearity and linearity as well, although the question is only on time invariance. Okay, any separate function of time? No. Any change in bracket time? No. This is time invariant. Option number B. Okay, this is linear. Y depends on x power 1. This is linear. But separate function of time, I clearly explained you, time variant. Option number D. Now, separate function of time, not there, but t becomes minus t. T becomes minus t. So again, time variant. Changes in bracket time, changes in time argument. Okay, y depends on x power 1. This is linear. Okay, y depends again on x power 1, linear. The same example I explained you actually. Changes in time argument, time variant. Okay, so only one answer is time invariant. Only one option correct. MSQ with one option correct is quite possible. MSQ, even one option can be correct. One or more. Any number of options may be correct. 1 correct, 2 correct, 3 correct, 4 correct. Anything can be seen in MSQ. The only answer is A here. Correct? The only answer is here. A here. The only answer here is A. Got it? Okay. So see, when I told you any changes in time argument. Okay. Any changes in time argument. Okay. So if I write down time scaling and time folding, like in our question, time folding was given. So if time folding or time scaling is given, then the system is time variant. Then also the system is time variant. Okay. Now, if it is given in the differential equation form, you have to comment linear and time invariant system. See very clearly, y cube. Okay, this cube makes the system non-linear. Okay, this cubes make the system non-linear. Okay. Now, with input or output anywhere, separate function of time. Okay. What is the doubt in sine xt, Dharun? Please tell me. Sine of xt. That I explained in the linearity. You specify what doubt exactly it is so that I can help you more. Now, anywhere separate function of time multiplied, like t. Okay, with input, output, or with the derivative, then also the system is time variant. Separate function of time. Okay, this is separate function of time. Separate t term. Okay, time variant. Y cube, non-linear. So it is non-linear and also time variant. Answer tick mark to be D. Same logic you apply to the differential equation. No need to derive and prove every time. Okay. All right. Next question. MSQ again. Which of the following system is or are non-causal? Okay. Which systems are non-causal? Where the output depends on future also. Whenever the output depends on the present or past values of the input. Whenever the output depends, okay, on the present or past values of the input, that is a causal system. Okay. That is a causal system. If the output depends on present and or past and also on future, okay, when future values are involved, then the system is non-causal. Okay, non-causal also further categorized into simply a non-causal. Okay, simply a non-causal, like both-sided non-causal. Okay, like both-sided non-causal, a system whose output depends, present, past as well as future. But anti-causal means strictly opposite of causal. What is causal? Understand this way. Non-causal can have anything, present, past, future, but causal means only present or past. So what is the strict opposite of it? Strict opposite of it means only future. Okay, only future. Okay, so output depending only on future values will be strictly known as anti-causal. Will be strictly known as anti-causal. Okay. All right, some doubts are there. Okay, let me come to that. Okay, by the time you can answer. So, MK say if it was only yt instead of y cube. Okay, the previous question, let me check the other terms. Yeah, if it was only yt, it is linear because rest all the terms. See, what is required for linearity? Input or output or any of the derivative, everything must be in first power. Okay, xt power 1. Suppose if this was yt, first derivative power 1, second derivative power 1, yes, it would be linear. Correct, MK? 100% linear. Okay, Dharun, you are asking about sin x. See, what is the y? See, output is sine of x. What is the input versus output curve? Is it a straight line passing through origin? No, no. What is y equal to sine x curve? Whenever you have a straight line, y versus x as a straight line passing through origin, then only linearity. Otherwise, the official method is try additivity and scaling. Na? Try additivity and scaling. Okay. If two inputs are added, will the outputs be added? Okay, so sine of x1 plus x2, can you break like this, sine of x1 plus sine of x2? Do you know any such trigonometric identity? Sine of a plus b equal to sine a plus sine b? No, na? Sine of a plus b, sine a cos b plus cos a sine b. Is that okay? Is the hints enough, Dharun? Okay. Yeah. Yeah, coming back to the question. Yeah, tell me this one. No, Satyam. Okay, I'll comment on to that. All static systems are causal, correct, but all causal systems are not static. That is absolutely correct. Vice versa, not correct. Okay. All dynamic systems are non-causal? Yes. Okay. But vice versa, all non-causal systems are dynamic? That is correct only. No? That is non-causal means somehow future is coming. That means it is not dynamic. That means it is dynamic. Sorry. Okay. Got it, Satyam? Right. Yeah. So now see here, output to be calculated at time t, input required at t and t minus 4. Input is required at t and t minus 4. What is t? Present. What is t minus 4? Past. Only present and past, system is causal. Okay. Output required at t, so t minus 4, you going back is past, but 4 minus t. Minus t can go to future or past, anything. Why? I will take an example to explain you. Okay, suppose you wanted to calculate y1. So that becomes y, or let me take some more better value. Suppose you wanted to calculate y5. So answer will be x of 1 plus x of 4 minus 5 minus 1. Okay, then this is past. With respect to 5, minus 1 is back, past. But if you wanted to calculate, suppose y minus 1, let me write here, that will become minus 1 minus 4 minus 5 plus x of 4 minus minus 1. If t is minus 1, 4 minus minus 1 is 5. You are calculating output at minus 1 and input is required at 5. That is future. Okay, that is future. Okay, that is future. Got it? Okay, so future elements can come, so this is non-causal. Okay, next, integral, simple one. Integral, output is integral of the input, but integral from what to what? Integral minus infinite to 2t. Let me break this integral like this, integral minus infinite to t plus integral t to 2t. You are integrating the input from t to 2t. Okay, t to 2t means future. Because output is calculated at t and the values of the input are required from t to 2t. Anything more than t is future. Okay, because future is required, so this is non-causal. This is up to present and past, but this is future. Okay. Okay. This is t plus 2, directly future. Output is required at t and you are going to the future. Okay, this is non-causal. Now see here, difference. The answer D is non-causal, but answer D is that option where output depends only on future. Okay. Future means here only future. Only, if the output depends only on future value, you can call the system also as anti-causal. Anti-causal is a type of non-causal, but you can specifically option number D call it as anti-causal. Okay, but is it non-causal? Yes, you can choose the option. You have to choose the non-causal option, MSQ question BCD. BCD. Okay, BCD is the correct answer as of now. Okay, dear, fine. Okay. Next question, number 18th. Yeah, MSQ question, yet another MSQ question. Come on, take this one. If yn is the output for a system with input xn, which of the following statement is or are correct? Okay, yn equal to nxn is non-linear. No. Okay, y depends on x power 1. Separate function of time does not affect linearity. That has something to do with time invariance. So this is non-linear. No, this is linear and time variant. Separate function of time, time variant. Okay, so A answer is wrong. They are asking non-linear. No, it is linear. B answer, 1 by 3 xn plus xn minus 1 plus xn minus 2 stable. Okay, okay, let's come to option number B. Just wait. It is possible for a linear system to be non-causal. Yeah, these are two different concepts. Yes, definitely a linear system may be non-causal. Okay, a linear system may be non-causal. Suppose yt equal to 5x t minus 2. Y depend on x power 1, linear. Okay, and sorry, xt plus 2 like this. Okay, but to calculate output at t, future values are required, means non-causal. So it is definitely possible for a linear system to be non-causal. These are two different things. D answer. Now yn equal to 1 for xn greater than equal to 0 and yn equal to 0 for xn less than 0. Is it linear? Okay, I'll write down this. How the D answer is given. Yn equal to 1 for any input xn positive. Okay, for any input xn which is negative, the output is 0. The output is 0. This is the yn. Correct? Now, I'll take a simple example. Is it linear? Okay, it has only two values, 1 or 0. Okay, suppose you take input x1 as 1. Okay, if the input is 1, which is positive, output will also be 1. Okay, you take x2 as suppose 4. Output will still be 1 only, because for any positive input, output is 1. Okay, now you take the input 1 plus 4, which is 5, x1 plus x2. What is the output? Input is 5, again positive, output is 1. Okay, is the output equal to y1 plus y2? No, no. y1 plus y2 means output should be 2, but output can never be 2. Output is either 1 or 0. So what fails? Additivity fails. Okay, the system is non-linear. So D is wrong. Okay, C was correct, coming to the B answer. Okay, coming to the B answer. What is only left is B. Okay, so have a look into it. Okay, have a look into this one. BIBO stable versus unstable system. Okay, the stability is always decided as BIBO stability. Bounded input should produce bounded output. Okay, bounded input should produce bounded output. Okay, whenever any bounded means finite input applied and the system in response, in return produces a finite output, then it is stable. Then it is stable. So see here, if input is bounded in this example, okay, if xn equal to finite for all n, what will be yn? Okay, some finite number, it may be different finite numbers, but it will be finite plus finite plus finite. Okay, if input is always finite, you have to assume input always finite, so output is always finite only. Okay, if finite input produces finite output, the system is stable, so B answer is also correct. So what are the correct answer for the question? B and C. Right, A was wrong, D also wrong. B and C are the correct answer. B and D are the correct answer. Okay. Right. Yes, you can check the causality for option D, MK. It is going to be causal. See, to calculate output at any instant, the input is required at the same instant, only present value, causal as well as static. Okay. To calculate output at any time t, input value is required at the same time t or n. DD question it is, okay, but the same concept. Okay, you can check causality and it is causal only. It is causal. Okay. Right. Okay. Statement for questions 19 and 20. Two questions, okay, where you have to consider all the four properties: time invariance, linearity, causal and stable. Determine which of the above properties hold for the system given in the question below. No, even if you multiply Satyam by any number, any finite number 1 by 3, then also result is finite. Now I have simply written answer as finite plus finite plus finite. That is important here. That 1 by 3 is not important because that is finite number. That is why it is not important there. Yes. Tell me. Now let's answer this quickly. Let us answer this quickly. Y depending on x power 1, linear. Okay. Separate function of time, time variant. Okay. T plus 5, future. Okay. Future, non-causal. Okay. Now, last, if xt is finite, okay, then yt, which is cos of 4t multiplied by x of t plus 5. Okay. Time shifting doesn't change the amplitude level, so it is finite into finite. Cos theta is always between -1 to 1. Cos theta is never unbounded. So finite into finite, finite. Okay, so if input is finite, output will be finite only. So it is stable also. It is stable also. So it is linear and stable, but not causal and not time invariant. It is linear and stable. Answer is C. Linear and stable. Answer is C. See guys, I am showing you the question and solving also parallelly, but if you see you have understood and if you can get the answer, you can pause the video, you can try your own and you can just match. Your answer should be C, linear and stable. Come on, next one. Yn equal to tan of xn minus 2 plus xn. Now see, tangent, okay, y equal to tan of x function, okay, this is non-linear. Only x power of one function, not inside tan, not inside cos. Many times I told you. Okay, so it is non-linear. Okay, now see, any separate function of time? No separate function of time or no change in time argument like n square or n cube inside the bracket. Nothing. Okay, nothing. Okay, it is time invariant. It is time invariant. Okay, this is past. To calculate output at n, you require input at n which is present. Only present and past. Okay, so it is causal also. Only present or past. No future required. It is causal also. Okay, it is causal, non-linear and time invariant as of now. Stable. Stable. If x of n minus 2, okay, if this value is suppose pi by 2, then what is the output? Tan of pi by 2 plus something. Okay, that I don't require because tan pi by 2 is infinite. That means if I take a finite input, pi by 2 means 1.57. Pi by 2 means 1.57, which is finite. For a finite input, we have got an infinite output, unbounded output. So the system is unstable. Unbounded output, so the system is unstable. Okay, so it has satisfied which property? Only causal and time invariance. Option number C. Option number C. Not D. Not D. Okay, some of you are telling stability. No. It is C. Correct, Sai Bhargav. Correct, Balaj. Correct, Bala Rajeshwari. Correct. Now it is not stable, Satyam. Tell me how it is. You take this value. Okay, tan pi by 2 infinity. Pi by 2 is a finite value. Okay. Got it? It is C. It is C. Okay. Unstable. Okay. 21. And the last question of the day, MSQ. 1 upon 2m plus 1, yn it should be, okay. Y of n. 1 upon 2m plus 1, summation k is minus m2 plus m x of n minus k. The system is linear, stable, causal or non-causal. Okay, if I just expand the summation, 1 upon 2m plus 1, k equal to minus m. So x of n plus m. Okay, in between minus m to m, 0 will come. So you will get x of n. And then x of n. Okay, k equal to m. So x of n minus m. Just I have opened the summation. If you open the summation, you are calculating output at n, where a present value of the input is also required. All these values n minus 1 up to n minus m will be passed, but left side n plus 1 up to n plus m, all these will be future. So it is non-causal. It is for sure non-causal. It is not causal. It is non-causal. Okay, but is it stable and is it linear? See, it is definitely stable. Why? Because if xn is finite, if input is always finite, finite always means if it is finite for all n, okay, then how the output is calculated? 1 upon 2m plus 1. It is like an average calculation done. Okay, finite plus finite. Okay, different finite numbers. Okay, some different finite numbers are there. Total 2m plus 1 numbers are there. Okay, but the net answer will be finite only. Now, whenever you add finite values, okay, finite number of finite values, you will get the answer as finite. Okay, so the output will be finite. So the system is stable as well. So the system is stable. B. Is it linear? Is summation and integration operations are linear. Okay. Summation x1 plus x2, whenever you are doing, you can easily split it as summation x1 plus summation x2. Okay, it is linear. It is linear. Option number A. Okay, or otherwise what you can say? Otherwise what you can say? Output depending on x power 1. All the terms are x power 1. Okay, if I split also, this is x power 1. Okay, output, okay, depending only on x power 1. All x power 1 terms. So it is linear by our direct observations earlier. Okay, so anyways, it is linear and then stable and non-causal. A, B and D. 3 answers correct here. That is A, B and D. Hope that is in your catch. Okay guys, so yeah, 21 questions done. It's around 2 or more than 2 hours of the session. I'll give you some quick updates before closing the session. And I will also be sharing the PDF of today's session in my Telegram. Okay, but as a rule, my PDFs are always password protected. The password for today will be causal. The password for today's PDF will be causal. Everything in small. I repeat, everything in small. Everything in small only. C-A-U-S-A-L. Everything in small. Causal. C-A-U-S-A-L. C-A-U-S-A-L. Okay. Right. Those who are dedicatedly watching the video, those who are learning with the video, the PDF is only required for them. Okay. That only makes sense. Okay. So if you have watched the video, you have the password. Otherwise, okay, the PDF cannot be accessed. Okay, guys. All right. Okay, have a look into this one. Okay, just a second here. Just a second. Yes, guys. So for all the GATE 2026 champions, the OM Institute brings to you, okay, the free mock test, okay, for EC and EE. Okay, the free mock test for EC and EE. I'll show you the Telegram link also. Okay, so you can experience the real gate, the gate feel, okay, with the exact gate pattern, the questions designed by expert faculty on this 10th of January. Okay, exactly as per the EC and EE official exam slot. Both the EC and EE this time are in the morning slot, 9:30 a.m. to 12:30 p.m. And also there are exciting prizes for the top 5 rankers. So don't miss this opportunity and register for this test. Okay. Also guys, if you need a quick revision course so that you enhance your revision for gate 26, and if you want to revise the entire concepts, okay, especially focusing more on how do you solve the problems, that ability if you want to develop, okay, you can also take the online crash course, a recorded one for gate 26, okay, the fee for which is 8,500. Okay, so if you or your juniors are going to plan for GATE 2027 or 28, the first online live course, okay, for GATE 2027 and 28 has been announced, and that starts from 2nd of February. Okay, for 1 year the fee is 1999 for GATE 27. For GATE 28, 2-year validity will be 28,999. There will be offline batches also for GATE 27. That also we are going to announce very soon. Okay, offline batches at Hyderabad for GATE 27. The dates will be announced very soon. Okay. All right, but for this course starting from 2nd Feb, if you register till 10th January, okay, or before it, you get additional 20% discount, and at the same time 2 months of extra validity. Okay, just have to use the code OMGATE20. All right guys, if you're preparing for the state AE examination, okay, for the AP or Telangana Genco Transco Discoms examination, the online live course recently started 14 December. You can enroll onto it. The fee is 24,999, or if you have any OM student taken any type of coaching from OM earlier, online or offline, you also get 30% discount. Okay, and okay, the new offline batch, okay, for the Gensco, Transco and Discoms, okay, will be starting on 21st of December. Okay, yeah, this is the link of the Telegram. You can search the Telegram using this. Okay, those who are looking for Telegram, because the PDF I'll share it mostly by tomorrow. If I'll try for tonight, otherwise tomorrow I'll share the PDF 100%. No, Fourier transform also I will take, but day after tomorrow. Okay, see, tomorrow, that is 17 December, you will have a session on networks. Okay, then 18 December, again I will have signals. And in the signals, we will have LTI systems. Okay, LTI systems and the convolution. LTI systems and convolution. LTI systems and the convolution. Yeah, Sai Sharma, there is a revision crash course recorded available that I just told you. Just rewind the video 2 minutes back, you will get the details. Okay, so I will come back again on 18 December, guys. At the same time, we'll discuss the concepts and questions on LTI system and convolution. Next session, I will take on Fourier transform. Okay. All right, guys. Okay, so bye-bye. Thank you. Stay safe. Any more further doubts? Okay, the session is already 2 hours more beyond. I'll close the session, but any more doubts regarding to today's question, you interact with me in the Telegram, or within the same Telegram, you can find me as well, and you can directly send me the message. You can DM me the doubt. Okay, if you don't want to discuss on group, you directly DM me the doubt, I'll reply you. Okay, bye-bye. Good night. Stay safe and take care of yourself.